Hey guys, time for some practicing of colligative properties. So I have two example problems here that we're going to work through. So the first one, can you see it? Yes. Okay, the first one asks, what is the freezing point? I'll stand over here. Of 0.75 molal of a 0.25 molal aqueous solution of aluminum sulfate, and I gave you the KF. So we're going to go ahead and solve this using our colligative properties formula. So we're going to use the formula delta T equals Kf times M times I. So we're looking for delta T. The Kf was given to us for this. It's 1.89. Our molality was given to us, 0.75. And then we need to find I. Looking at aluminum sulfate, aluminum is metal, so this is going to be ionic. So we have 2 aluminums and 3 sulfates. So I is going to be 5. So I'm going to multiply this all together. Again, put it in my handy dandy calculator. 1.89 times 0.75 times 5 equals 7.1. So I get a delta T equals 7.1 degrees Celsius. Now, remember, this is not the new freezing point. That's how much the freezing point changes by. So we need the normal freezing point of this. And the trick here is recognizing that aqueous means this is in water, and the normal freezing point of water is 0. So I'm going to take the normal freezing point of water 0 minus the freezing point or the change in temperature I just calculated. So I'm going to get a new freezing point of negative 7.1 degrees Celsius. Okay, so that's the first problem. Let's work on this second problem. Okay, the second problem is going to take a little bit more work because I didn't give you the molality. Of course I didn't. Okay, so on this one, we're looking for the boiling point when 65.2 grams of ammonia are dissolved into 250 grams of ethanol. I gave you the KB and the normal boiling point of ethanol. So we're going to use our formula again. Delta T equals KB this time because we're doing boiling point times M times I. I'm going to have delta T equals KB, which I gave you. But now I need to calculate M. Remember, M is moles of solute divided by kilograms of solvent. So I need to take my ammonia and convert it to moles. So I'm going to take my grams of ammonia and I'm going to divide by its molar mass. So I'm going to take the mass of ammonia plus 3 times the mass of hydrogen, which is going to be 17.04 grams. Yes, I have that memorized. I know, I'm a nerd. And I'm going to divide them. And I get out 3.83 moles. I'm going to divide this by my solvent in kilograms. So I have 250 grams. To get it to kilograms, I'm going to divide it by 1,000 or move the decimal place to the left 3 times. So that's going to be 0.250 kilograms. So now I can divide those, and that will be my molality. 3.83 divided by 0.250, and I get out a molality of 15.3. Okay, so I have my KB, I have my M, now I need my I. Looking at NH3, this is ammonia. It starts with nitrogen, which is a non-metal. So that means I is just 1 because if it starts with a non-metal, it's covalent. It won't split into ions, and so it's going to stay 1. Okay, so now I can multiply these together. 1.22 times 15.3 times 1, and I'm going to get a delta T of 18.7 degrees Celsius. Remember, delta T is not my final answer. For my final answer, I need to add this to the boiling point. I subtract from the freezing point, I add to the boiling point. So I'm going to take 78.4 degrees Celsius plus 18.7. And I get 97.1 degrees Celsius as my new boiling point. I hope this helps you figure it out.